Good morning, ladies and germs. Let's see, today we're taking care of the toner. We're going to do a reverse engineer. We're going to get the schematic off from the circuit board, from the PCB. And I don't know how long this video will be. I have no idea. This might be a three-part video because one is going to be, here's my plan of attack here. We'll open it up. I haven't been in here in a long time, just to replace the battery, and that was like a year ago, and it's pretty dead in there. But and I've been wanting to take this apart and redo the schematic, just so I have a copy of it, and redo it so that I can put it in another enclosure, and that way I can just roll my own, you know. And it's a good product to have. It's a great time saver if you're doing any kind of structured wiring installs. So yeah, you're gonna want that. Let's see. Yeah, so let's open her up. Let's see what we got. Let's see what we're working with. We'll just do the circuit board today. So we're gonna translate I'm gonna take pictures of top and bottom, and we'll do the trace layouts for the board, and I'll probably do that on software. I might do a rough sketch on paper, and that's not going to look pretty because it just won't. So I'll probably redo it in KiCad. That's my schematic software that I prefer to use. And so if I can find a screwdriver, we can begin. Where is it? There we go. Change the tip up. Okay, so yeah, grab a coffee, something to eat. This might be a long video, I'm not sure. I have no idea. I've been wanting to take this thing apart and redo the schematic on this, just so I can have a record of it for a long time. So, okay, so here's the inside here. We can take the battery out, and I'll probably replace the connector for the 9-volt snap. I got much nicer ones than this. They're from Keystone. They're real nice. Anyway, so yeah, I guess this part comes off. This is attached to the switch. And let's see where we go. The last time I was in here was adding my RJ11 and RJ45 jacks to it. Yeah, it's not that bad, and I remember having I guess I had to repair the switch. That's those 3 contacts there. Here, here, and here. And working through the camera, it's a little difficult for me to point at things. But yeah, there's some serious damage to the board. And yeah, so we're just going to redo this. And here's the top. Looks like we have a bicolor LED. Some filtering caps that's probably handling the timing. I'm not sure what type of chip that is. Ooh. That's why I never did it. Oh, look at this. It's scratched off. This will be an interesting video then. Because, wow, yeah, we're going to have to figure out what this baby is. How do you do that, right? Well, okay, well, typically how we could do that is, I'm going to do it I guess I'll do it the old school way, and just a resistor and a voltmeter. And we'll have to draw out a truth table. I remember having to do this in school, and that was one of the homework assignments. You know, you had 48 hours to come back, and everybody got an IC. It was either a 4000 or 7400 series. And the project was, come back with a truth table and identify the chip. This is a son of a bitch that was one hell of a project. So, and half the kids failed the class within the first hour because they tried powering it up, and they just toasted it and burned it. That was it, man. That was it. And the guy had it labeled, you know, the professor had the chip labeled, so that, and he kept that paperwork at home. He did not bring that into class because we would have stolen that shit. And but yeah, you can just use a resistor, and what you're detecting is the high and low levels for whether it's an input or an output. I'm not sure what this is actually. I don't even know if I'm getting ahead of myself. I don't even know if this is that kind of logic chip. This could be a microcontroller for all I know. I have no idea. One thing I will look for is the pin out. So if pins 7 and 14 are power or inputs, not inputs, voltage levels in and ground. So we're looking for positive voltage on pin 14 and negative on 7, right? Yeah. And that would be a good indication that we're dealing with a CMOS or a logic level chip, which is either 4000 series or 7400 series. This is running off of 9 volts. I don't see a regulator or well, I do see a diode. I don't know if that's, I don't know what type of diode that is yet either. But let's see, how do we want to go about this? So just looking at it, I'm looking at this now, and I really need to get a better way of doing this video stuff, right? I'm trying to get the damn thing to focus. Okay, well, whatever. Let's see, pin 1 is here. So this would be pin 1. Pin 1, that means pin 7 is here. And pin 14 would be here, right? And let's see, pin 7 looks like it's going to okay, well, pin 14 goes to the switch. That looks like our plus supply voltage rail. So yeah, it's looking like it's either, let me think here. If it's running straight off of 9 volts, that means it's not a 7400 series, right? Because 7400 series are typically just run off of 5 volts max, right? So we're looking at a 4000 series chip. And this is just off the top of my head. I have no idea what this chip is. I really don't. And but let's not focus on that too much right now. That'll be that's a whole nother video. I didn't even see that one coming. So let's just get the schematic down, and we can figure out maybe what we're doing by the schematic layout. Maybe we can even more figure out what this might be, or how it's doing it, depending on the traces. So I suppose we'll start at the input for voltage, right? Start there. So here we go. Get that coffee. All right. I'm going to switch the camera around, and we're going to get that going, okay? Yeah. Get into it. Typically, the first thing I'll do is get all the components and put them on the screen, right? And then we do the traces last, all right? And we'll label all the components by their designation, the designation numbers, or the identifying markers, any potential, values of components as I come across them. I'm not going to focus on that right now, but I mean, I'll certainly label whatever they are, okay? So yeah, let's start with that, and it'll be a lot easier to do it this way because it'll be a lot less paperwork and pencil time and all that crap. So all the components will just be on the screen, and just go and connect the dots, and as simple as that. Okay, so let's start there. Yeah, so first thing we'll do is we'll just slap all the components onto the screen here, and let's type in single pole double throw. Let's do that. Let's see. I'm not going to use my schematic. I'll use the original KiCad schematics. Let's see, I know I want plus 9 volts. Let's see, let's do battery cell. Let's do that. Let's get our ground. Let's get this established. Okay. Let's save it. Relocate this now. We have our switch. Let's see, this is going to be switch 1. Battery input, we got that. I know you have another switch, so let's get that on there. I'm going to use a pin header for that. Labeled connector. That would be a 1.2. Let's just do that. And let's see. Now, let's go with a switch. So let's copy that and we'll do that again. That's all. So that'll be switch 2. Okay. Let's see, I know we have outputs, so let's do outputs. Let's say that'll be that by that. Excuse me if I'm using shortcuts, the keyboard shortcuts. I use the letter R for rotate. That's what's happening there. I know this isn't a tutorial for KiCad, but I might as well talk about that too, right? Oh, by the way, this is going to be, I don't know how long this video will be, because I don't think I'm going to edit too much of it out. You're just going to see the whole damn thing. Let's see, so this is output. Let's keep that clean. Okay, real components now. Let's do a diode. This, I'll have that as D2. That's the wrong one. That'll be D2. It looks like a 4148. I can't tell. 1 in 4148. Yeah, just going through the motions. Let's see. Okay, a new symbol. And I want to put that in my files. Same. Right? Right. Let's relocate this stuff. Pen name. No idea. Pen 1. Type. Unspecified, big time. Three, 4, that is not that. That should be unspecified. And 7 would be ground. So that's a power input. And I know that this is ground. Right? Right. Let's see, might as well get VCC. That's pin 14. Okay, let's go unspecified. 8. Okay. Is that really centered? No. There we go. Okay, let's save that. Let's bring it into the part. Here it is. Our unknown part. Okay. Alright. Yeah. That's all the parts on the whole thing. It kind of seems too easy, right? Let's just do a connector. Let's go pin header. I can move this over so we can see what we're doing. We want 2.54. Let's do that again here. Let's see. I want a 2-pin vertical. So there's that. C1. I want to get the footprints properly done. That tells me another thing. That tells me that it's an off-the-shelf part, and it's a real common component. Real common. So it could be doing flip-flops. It could be doing inversions, inverting. It could be a hex inverter. It could be anything. I mean, what else could it be, right? Hex inverter? It's gotta be. I don't know. I have no idea. I really don't. I don't know. But we'll find out. And then to figure out what the actual part number is. Yeah. It could be mini. But the truth table will determine what that kind of component is. It won't give me an exact part number, but we'll just go with whatever the most commonly known part name for whatever it is. Gotta love software. This is so much better. Ah, this is gonna be cool. I've been wanting to do this for a long time. Let's see the 3D view. Yeah, so those are our parts, and we're gonna lay it out exactly the way here. We're gonna follow the traces, and we're gonna be good to go. Let's see. I want to do traces on the reverse side. That's very important. Okay. R5 goes next to it. R6 goes like that. Get another switch. That. I'll have it set up like so. Yeah. That doesn't matter. It's close enough. R6. That. Our LED. Pin 1 goes on top. Just like that. R7 is around here. R8. R8 is over here. Sideways with it. This gets out of the way. D1. This guy. And we're pointing down. That's good. Let's see, on 5 we got that, not that. We got the switch. How about the 4148? Let's get that one going. That goes just around here. Our IC goes around here. R1. RP. Number 1. That's C1. Positive goes on this side. C3. Just like so. Our battery 1 with positive. Like so. Let's see here. We're almost done. That goes there. Output goes like this. Yep. R9. Where's R9? R9. Wow. Huh. Oh, there it is. R9. Goes right about. What are you doing, Snap? R9. Come here, you. R9 is going to go right around, right about here. And let's see, let's put that right here. Get rid of that. And now we do some layouts. This goes here. I can't remember if that goes to the switch or not. It does. Let's see, this pin here goes to this side. This gets connected here. Don't ask. I don't know. I don't know. So let's see, that's that. This goes up here. It goes across. And there's R7. Go there. That goes here. That. That goes to pin 4. This pin and that pin is connected there. This goes up, back to R5. And 1 goes to the switch. Pin 5 goes to pin 10. Pin 8 goes to pin 6. Obviously this goes to ground. It goes like that, I believe. This gets connected to that. Okay, output, that goes to C3, right there. This goes to R3. This goes here. Whoops. This goes here. This goes to pins 6, 7, 8, 9. That should be 11. Let's see. Shows 8, 9, 10, 11. Right. And 10 goes to pin 9. This goes to R2. This goes to pin 8. This here goes to this guy. And this gets connected there. Power goes to R7. Diode goes to ooh, I screwed up. That does not go there. Yup. Bad. That goes to ground. Okay. This here goes to the diode. Good. That's right. Yeah, that's looking much right. Let's see, this is that. R9. R9 goes to C1. Negative on C1. Let's say pin 1, which is not what we're doing. We're going to do this. That goes to our main voltage in. Pin 13 goes to right here. That. This goes to here. Let's see, what else? Am I done? No. Where's that other D1 go? D1 here goes to here. And 3. Jeez, this thing is amazing. Let's go with that. That goes to that. This goes to R7. Right here. This goes to D1. So D2, we got that right. Whoops. That goes like that. Let me verify the orientation for that. Ooh, we're missing R8, aren't we? Yep. And that goes to this side. Done. I don't think I've missed anything. Okay, now we'll do the import for the new net list, and it should match up to what we have here. Can't be undone. What happened to our parts? I'm missing components here. What else? R7 needs to be flipped. Okay. Switch 2 needs to be flipped. I think that's right. Oh, that was switch 2. Wrong. R9 needs to be flipped. R2 needs to be flipped. Do the net list. Come on, Bobby. Set the net list, generate, come back. No. Switch 1 needs to be switched, switch 2 needs to be switched. We're getting there. Wow. Is it accurate? Ha! We got it. Fucking perfect. Nice. Okay. That was a long video. Holy cow. Hey, we did it, right? Okay. That's what's important. Let's take a look at what it looks like in 3D. Whoops. That's not the 3D button, Bobby. Let's see what she looks like. Yeah. That's pretty much the board, isn't it? Yeah. That's the board. Just doing a quick comparison here. We're done. We're done with that. And I'm flipping the board over so that I'm comparing it literally to this. So I'm going to do that right now. Yeah, this looks great. Yup. 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 Yes. 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 Yep. Yep. That. Mm-hmm. Mm-hmm. Yep. 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 Okay. Uh-huh. Yep. 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 Oh, we got this. Done and done. Okay. We did it, right? Okay. So, there's the schematic. We need to figure out what our mystery chip is now. That'll be fun. Yeah. Okay, so, our mystery chip. Let's change that to a question mark. I'm going to say a 4000 because I know it's 4000 series something. Yeah, because there's no voltage drop resistor on, there's no Zener diode clamp, anything like that. Ooh, what's happening here? What was that? Do a design roll check. Perfect. Fine. Okay. Let's do that. Yeah. So it's a 4000 series something. I know that because there isn't a Zener clamping diode that would drop it down to, like, say 5 volts. If it was a 7400 series chip, it would probably they definitely run on 5 volts, right? Because they're transistor logic stuff. So I'm guessing it's a 4000 series because they have a higher input voltage. So I'm guessing that that's a 4000 series. Let's see. Yeah, what's next is the values for the components. Do we need to know that? I mean, do we need to do that right now? Do we really need to do that? No. I'll fix that up later. We can do that. I can do that. And so yeah, there's the schematic there. I'll have it finalized, I suppose. But we still need to figure out what that mystery chip is. Got to figure that out. That will be the next video. Yup. Okay, so thanks for watching. Good night, ladies and germs.